Hello everybody, can you hear me? Is there any problem? Thank you very much. I hope everything is okay and you can hear me now. Okay, let's share the presentation. Thank you very much, I'm fine. I hope everything is fine for you also. Our number is low today. Usually there would be about 30 students, but now it's just 16. Maybe people will come. We can wait 3 or 5 minutes to start. Now I think you can see the presentation. Okay, let's wait 2 minutes more, maybe people come. Please keep your pencil and paper with you, because we will do some exercise in this lecture. In this lecture, we will learn about the Carnot maps, Carnot diagrams. Somebody says, but we will learn about the Carnot maps and what is it, what it's worth for. But before starting the lesson, I noticed that in the last week there is a lack truth table information, because when we try to solve some exercises, if it's about the expression or calculation, you guys answer, but in the truth table I noticed that there wasn't any answer, and I want to do some exercises about the truth table. Then we will learn about the Carnot map, and we will learn about the simplification. So let's start. As I said, I want to solve some truth table example. I'm beginning with the simple one. I think you have paper and the pencil. Can you please fulfill this table? Please fulfill this table. This is very simple. You have two inputs, A and B. You have one interconnection, this one, A and B, the result of the AND gates, and you have the final results, not A and B. Can you please fulfill this table, and if you're done, please write done in the chat area. I think first one you say 0, 0. Okay. Okay. Nope. The first one was true. Amer, Ebu, Al-Rub. Let's do this. Let's fulfill these tables. There is a and B. AND gates, you know the AND gate. If the all of inputs are 1, then results is 1. Otherwise, the all of variation is 0. Like that. 0 and 0 means 0. Sorry about writing. 0 and 0 means 0. 1 and 0 means 0. And there is a 1 variable. Both of the inputs are 1, so results is 1. So it is A and B. So not A and B is just inverted. It's just the flip. 0 means 1, 0 means 1, 0 means 1, 1 means 0. It's a truth table. So that is the results. As you see, there is the AND gates. You all know about the AND gates, and there is only one NAND gate, and the result is just a flip, just invert to A and B. Okay, let's do this. There is also 2 inputs, and you have 1, 2, 3, 4. 1, 2, 3, 4 interconnection and 1 result. Can you please fulfill this table in your paper? Done is enough. Just write done if you done the table. You don't have to write answer. There is 2 NAND gates. It's the simplest one. You have to write not A, not B. Just flip the variable and use these variables to input of the AND gates and find the results of the AND gates. There's the 2 results, and use these 2 results to input of the OR gates and finally find the final results. You know AND gate and OR gate. Also you know NAND. There is a unary and the other gates are binary. You know this answer 1, 1, 0, 0, right? You know also this answer 1, 0, 1, 0, right? Okay, let's do that. Please write the chatting area this answer. I and not V. Please write it. Like Mariam Al-Otari writes the not B, please write the A and not B. If you're done, I'm asking just this line. I only ask this line. Yep, it's true. There's 2 inputs. Inputs are A and not B, right? these two inputs and results in here, and only one is the both of is one, this one. A is 1, B is 1, so the result is 1. Otherwise, A is 0, it means 0, 0. A is 1, not A is also 0. Okay, let's write this one. Not A and B. Okay, perfect. And write this one, the results. Okay, can you hear me? There's a full adder. You will use a lot these circuits. It is very common, and you have 3 inputs, you have 2 outputs, and you have 1 interconnection, but it's not in the table. Please fulfill the sum and carry out. You have inputs, you have 3 inputs, so you have 8 variables. Okay, let's do this in order. Can you please say this one? A plus B means 0 plus 0, it means 0, right? Carry bit, it's just like the decimal. You are doing a calculation. You are doing a sum calculation. It means addition. Just think about the decimal addition. A plus B means 0 plus 0, and result is 0, carry is 0. Just like decimal. 0, 0 carry in is 1. What about that? You have 1 carry in and 2 input is 0. It means sum is 0, carry, sum is 1, carry is 0, right? This is just an addition. Don't think complex. If you do these gates, you must get same result. You just should do the addition. Just think about decimal number, not binary. Just think about decimal. Okay, 0 plus 1 means 1, and you have 0, right? Okay, let's do this. You have 0 plus 1, you have 0 plus 1, and you get 1, right? 0 plus 1 means 1 in decimal. But you have 1 carry bit. So think about you 5 plus 5. What would you get? You get 10, right? Just 5 plus 5, you get 0, and the carry is 1, and you get 10. It is the same rules in the binary system. There is a 0, there is a 1. It means 0 plus 1 means 1, and you have 1 carry bit. It means 1 plus 1. It means 0 and 1. Also this one, 1, 0. Also this one, 1 and 1, 0, and carry is 1. And also this one is 0, and carry is 1. This one is sum is 1, carry is 1. This is the full adder, and it is very, very, very important. You will use a lot. We will do some exercises about the addition with the binary numbers. I think there is also lack of the information in you guys, but don't worry, we will do a lot of exercise after we learn the Carnot map, and I will start beginnings and do a lot of exercise about the all of lecture. So you saw the full header now. Let's start the Carnot map. We will learn in this class minimum form of switching function, and we will learn 2 and 3 variables of Carnot map. We will learn 4 variables of Carnot map. We will learn determination of minimum expressions, 5 variable Carnot map, and we will work with study on other uses of Carnot map. But we will not see the other forms of Carnot map. Maybe it's not this lecture. Maybe later we will see them. In this lecture, given a function completely or incompletely specified of 3 to 5 variable, we will learn about the plot it on a Carnot map. And the function may be given in the min term and max term, all algebra form. You know the min term, you know the max term. Also, you know the algebra form. Determine the essential prime implicants of the function from the map. We will do that also. And we obtain the minimum sum of products and minimum product of sum. That was the min term and max term, right? Sum of products, product of sum. Form of a function from the map. Determine all of the prime implicants of the function from the map. We will do that also. And we will understand the relation between operation performed using the map and the corresponding algebraic operation. So, why we use the Carnot map? Why it is so important? One of the objectives of the digital designer, and you will be a digital designer, I'm saying again, one of the objectives of the digital designer, when using discrete gates, is to keep the numbers of gates to minimum and implementing a Boolean function. When you're using the implementation of Boolean function, you have to use the minimum gates, number of gates. The smaller the number of gates used, it means the lower the cost of the circuits. And cost is very, very important. You have to reduce the cost of the circuits. So I'm saying again, the smaller the number of gates used, the lower the cost of circuits. Simplification could be achieved by purely algebraic process. You know that already, because we saw some postulates, some rules to simplify the circuits or expression or some process. You can simplification by purely algebra process, but this can be kind of boring. It took too time to simple any expression, any circuits with the algebra process. And the designer not always sure that the simplest solution has been produced at the end of the process. You cannot be sure about that. It is the simplest one or not. You cannot know that. In algebra process, it is also very difficult to know that, and you can get confused. Is it the simplest one, or I can do more simplification with this expression? So there is some terms about the simplification. You know this term, x and not y, or x and y equals x, because when you do this x parenthesis not y and y, what is this result? Not y or what? What is the result? Come on, you know that. Not y or y. Just give a number and do the solution. Yep, it is 1. You can say the one 0, it is not important. You can say the y 1, it's not important. Results always will be 1. And x and 1 means x. This is so simple. And a given term may be used more than once, because in the binary calculation, in the Boolean algebra, there is no 2x, right? Or there is no 2z, or there is no 2y, 3x. You get only x or y or z or a, b, c, whatever you want to call it. But there is no 2 in here. There is only 1. It means x plus x. It means x or x equal x. So eliminate redundant terms by using the consensus theorem. You also know the consensus theorems. I recommend that you do memorize, especially De Morgan's and consensus theorems. Please memorize both of theorems. In the postulates, you will learn it with a lot of exercise. So find the minimum sum of products. It is the algebra produced. We said that algebra process is not easy one. It is the boring one. It took a lot of time, and you cannot be sure about that. But let's see that what they do with the simulation of the algebra process. We have this expression. It is just an example. We have mean term in here 0, 1, 2, 5, 6, 1. You know the mean term means, right? You know it's in the truth tables, these variables are 1. In the mean terms, we took the 1. In the max terms, we took the 0. So it use in here the two inputs expression. There is a two expression, and in two expression there is a similarity. Both of them has not A and not B, right? Let's look at this. I don't know, I can erase. Okay, just look this one. There's a similar term in both of them. What is that term? Is A, not A, and not B. And if we do the parentheses, we get this one will be 1, and we got the results, not A and not B. Right? It is the simple. So they do that with all of expression, like this one, and this one, and this one, and those two, and get the simple results. They say that. And also you can do this expression. They are same, right? They are same f, they are same expression, but the result is not same. Which one? The simple one. Simples. This one, right? This one is more simple than this. But how can we know about that? We can do this one also. We can do this made for. We don't know. The answer is same, by the way. This expression is equal this one. Answer always same. It does not change. So which one do you prefer to use? Do you prefer to use this expression or this expression? You prefer this one, right? Because this is simple. So there is also product of sum. The same rule is for the find a minimum of product of sum. This means max term, right? You can use the same rules. There is a one expression, there is the other, and you get this from those two. And you can use these two, you can use these two, you can use those two one, and you can get these results. Also, you can get again and simplify that, and you can use consensus rule and eliminate this one with consensus rules, and you can get simplest one. But as I say, it is the hard way. Let's see the easier way for that. Okay, there is a Carnot map. There is a visual solution, right? I think I can say that this one is computational solution. Maybe we can say that. And maybe we can say that this is a visual solution. And trust me, visual solutions are more reliable than the computational solutions, because visual solution you can see, you can make a decision easier. So let's see that. There is a two variable Carnot map. What does it mean? What does it mean, two variable Carnot map? It means you have two inputs. It is coming from truth table, by the way. You know, you must know truth table very well. It is kind of truth table, but as you see, it is some differences about the writing and create the table. You write the inputs like that. There is a and there is a B. A can be 0 and 1. Also B can be 0 and 1. So you have 4 square, right? You have big table, and in the table you have 4 square because you have 2 inputs. 2 power of 2, you have 4 variables, and all of variable you need, for all of variable you need a square in the table. So you have 2 inputs, you have 4 variable, you have 4 square. This square means A is 0, B is 0. This square means 0, 1. This square means 1, 0, and this square means 1, 1. You get the logic, right? This is very easy. So let's do that again. You have truth table like this. This is traditional truth table, right? And with truth tables, you can write the kernel map. You have 2 inputs and you have 4 variables. There's a 2 inputs and 4 variables. You know the A is 0 and B is 0. That means F is 1. And this square is 1. The square also 1, 0. A is 1. B is 0. A is 0. B is 1. And this means result is 1. Also the square is 0 and 0. You get it, right? It is very simple. So what is the square means? What does it mean in square for the expression? Let's see that. You always get the mean term if you didn't need the otherwise in the max term. Usually we use the mean term. We use the 1 always. So this one is A is 0, B is 0. When the value of the inputs is 0, it means not A and not B also, because B is also 0 in here. In the square, A is 0, B is 0. What about this one? In this square, this one, A is also 0, but B is 1. It means you have not A, not B, and you have not A, B. This is the expression. But it is not the simple one, right? Because for the simplification, you have to get the simplest one. So we can simplification this expression, right? We can get not a parenthesis and like this. We can do not a parenthesis and we get 1. Not B or B means 1 and we get A. So we can use kind of clusters. We can take the clusters but as a square. It must be square. What does it mean? It means it has to be 2 variable or 4 variable. It cannot to be 3 or 5 variable. It has to be power of 2. It has to be 2 or 4 variables. And you can cluster like that, like erase all of them. There's a square, as you see. There is neighbor, right? There's kind of neighborhood. And you have one square. 2 variable square you have. So let's look at this cluster. In this cluster, B is changing, right? B gets 0 and B gets 1. But if we look to A, it is not changing. During this cluster, during this square, A equals 0. So what is the 0? 0 means is not A, right? And the answer is not A. This is the way of the simplification. Just look at the table. Before look at the table, you have to write it. You have to draw the table, and you have to fulfill the tables and look them and say, is there any square with ones? Is there any ones near and 2 ones or 4 ones is neighborhood? You can draw the square and only you have to look which variables is not changing. Sorry, one. Okay, let's continue. Sorry about that, there was an interrupt. I am in work, so sorry about that. There is sometimes will be an interrupt maybe. Please don't leave the class, wait me. So you can draw this square and you can get which input is not changing and take it. Before take it, just look at its value because it can be 0 or 1. Important thing is not changing or change. You should get the not changing one and look at the number and take the value or the not value. So let's see that one. There's a 3 variable Carnot map. You have truth table. All of Carnot map came from the truth table. So you have truth table and you have 3 inputs. That means you have 8 variable, right? So that means you have to draw 8 square in your Carnot map, and there is a 3 input types. This is how you can write the inputs. One of them must be 1, one of them must be 2. So the one variable side, you have 0, you have 1, right? In 2 variable sides, in the 2 input sides, you have 4 variable, right? It means 0 0 0 1 1 1 1 0. There is a differences. Can you notice that? Can you notice something odd, something different in this calculation? 0 0 0 1 1 1 1 0. Maybe there is some difference in here because when we normally calculate, we use 0 0, it means 0. We use 0 1, This means is 0. This means is 1. And we use 1, 0. This means is 2, right? And we use 1, 1. This means is 3. This is 2 power of 0. This is 2 power of 1. And addition, the result is 0. When we count the numbers, we count like 0, 1, 2, 3. But in the Carnot map, when we calculate 0, 1, 3, and 2. Why? Why we don't use 0, 1, 2, 3? We use just 1, 0, 1, 3, 2. Why we prefer this? If any of you say the answer, he or she will get 5 points in first exam. Why don't we use 0, 1, 2, 3 and we use 0, 1, 3, 2? Why is that? Do you have any idea? Since 2 comes before 3. Yes, but in here there's differences. Why it comes before 3? Why it's different from the truth table? Just focus the changing bits. No, it is not about the numbers. Just focus the changing bit numbers. How many bits you have to change? For counting. Okay, let's see this. We count 0, 1, 2, 3. In 0 to 1, we change only 1 bit, right? We change only this one. In 1 to 2, we change 2 bits. 1 to 0, 0 to 1, right? Yep, we always choose the ones from the truth tables, and we always choose the changing just 1 bit. In truth table, it is not important how many bits you change. You just count it, 1, 2, 3, 4. But in the Carnot maps, you only change 1 bit. In 0 to 1, you change this bit only. In 1 to 3, you change only this one. It is the gray coding. I think we talked about the gray coding in the binary section. In the gray coding, you only have to change 1 bit, not 2 bit. If you try to write in here 2, because after 1 there's a 2, right? This similar calculation 1, 2, 3, 4. But if you write 2 after 1, you have to change 2 bits. You have to change 0, 1 to 1, 0. But if you jump to 3, you have only changed the 1 bit. This is gray coding. This is important because if you graduate the school, when you go to some interview, trust me, they will ask you about the gray coding in the interview, all of interview. So keep it your mind, in the gray coding, you only change one bit. Okay, this is the little information about the gray coding. So we have 4 variables in the 2 input sides: 0, 0, 0, 1, 1, 1, 1, 0. And you can fulfill you can fulfill the Carnot map from the truth table, right? 0, 0, 0 means 0, this one. 0, 0, 1 means 0, this one. 0, 1, 1 means 1, this one, right? And 0, 1, 0 means 0. There's a mistake. It must be 0. There is a mistake about that. So 1, 0, 0 is also there must be any mistake in the truth table. Okay, just to flip that, because there is some mistake about that. Let's do the other one. Let's do this one. Okay, you know the gray coding, right? 0, 1, 3, 2, and there's a 4, 5, 7, 6, because we only want to change one bit. So we got this one: 0, 0, 0, 1, 0, 0 means 4, 0, 0, 1 means 1, 1, 0, 1 means 5. So there is a number of squares. You have to know the numbers. If you create the Carnot map, you must know this variable. You must know the squares numbers, and came from the gray coding. It is the binary notation. It is the decimal notation. For the notation, you can use the decimal because you are used to it. So let's see that. 1 minute play, please. Let me see that. Okay, sorry. Where will you done? And okay, we will here. In Carnot map, you have this mean term, right? You have this one. There is a 1, 3, 5. There is a 1, 3, 5. It means mean term. It means 1, and there is a max term. The others is the 0. The others is the max term. You have this function: m1, m3, m5. So you know the numbers in here. So let's see some exercises. As I said, when you try to create squares, you have to use power of 2. If you have 2 neighbors like that, 1, 1, you have to take it. But if you have bigger one, if you have 4, just use the 4. This one. Just prefer the bigger one. Also, as I said, it must be neighbor like this one and this one. But in the corner, like this and this, they are also neighbor. You can get that as a square. Just like there is a stop and there is a continue. And you can finish the square. Just look at this. Just think about that. We don't use like a square. When we use the square, what we do that? You only have to look which one is not changing. Just take a look at this one. This one. You only look at the which inputs is not changing. A is changed, right? This one A is 0, this one A is 1. B, C is not changing, right? It's 1, 0. So it means B not C because C is 0. Because of C is 0, you get the not C and you get the results B and not C. Let's look at this. This one is the 4 variable square, right? You have 4 variables. Is A changing? Right. It gets 0 and 1 during the square. Is B changing? No. During the square, it is only gate 1. It is not changing. What about C? C is changing, right? It gets the 1 and it gets the 0. Only not change is B. The result is B. F equal B. And you got the simplest solution. So let's look at that. You have 1 in here and you have 1 in here. I said that you can get as a square in the corner one once. Because let's think about that. You don't get the square. What is this value? This means A not B not C, right? Plus this one. This one also means A not B and C. You can get the parenthesis of A and not B. You can get not C and B. Sorry. Okay, Hamza, you can talk.
Hocam, it's 1 minute. Hocam, it's A, not B, not C, plus A, B, not C.
Yes, it's true. Thank you very much. Thank you very much. Let's just correct them. It is A, not B, not C, A, B, not C. This not is belong to C. So you can get A not C parenthesis, and you can get not B, or B it means 1, and you can get A not C, right? Just look at SS square in here. You have this one and you have this one. Just think about square. Which one is change? Which inputs not change? A is not change. This is the one for both of them. So you get A. B is change. In here is 0. In here is 1. C is also not change, but it is 0. You get not C. Okay. Thank you very much, Hamza. And let's look at this one. I am coming 1 minute. Okay, sorry about that. So, given function. There's some rules about the given function. Let's see f. F a b c is equal this expression. We can say that, right? We can say that a is equal this expression. So, let's try to see the square ones. There is one square in here. There is one square in here also. You can use this one, but it is not. They are not prefer this one. Let's see why not. They say in terms A, B, not C is 1 when A is 1 and BC is 1, 0. So we place a 1 in the square which corresponds to A1 column and the BC equals 1, 0 row of the map. Okay, it's true. You can say that this is just one value. You can say that A, B, not C. Okay, it's not wrong. Just see the other one, not B and C. This one, right? This one, B is not changing, C is not changing, but A is changing. So it means B, not C. And this square, in this square, you can see that there is a not changing, and there is a BC is changing because they got the 0, 0 or 1, 1. So this result is A, not A. This one. And this function equals this expression. Okay. Let's see another one. We have this. Can you see the, maybe I can make it a little bit, this is better, right? Okay. But in here, okay, I can use the pencil. So there's a function. There's a mean term 1, 3, 5. It means this is 1, this is 3, this is 5, right? You can write like that, 1, 1, 1, and you got the Carnot map. And for the simplification, you have to get the squares. There's a 1 and there's another 1. So this one means not A because A is not changing. Also C is not changing. Not A and C. This one not B and C. And the result is F equal this expression. Okay. Take a look at this one. So we have this square and this square. As I said, in the corner you can get the full square because they are neighbors. Like this. In here they are neighbors 1 and 1. In here they are neighbor, but you can take the corner as a neighbor and you can see it like a 4 variable square. Just take a look in here and in here. Which one is changing? A is changing, right? 0, took 0 and 1. C is changing because in here C is, no, pardon, B is changing. In here B is 0. In here B is 1. B is changing. C is not changing. While all of 4 variables, it's only 0. So the result is not C for this. And for this, the result is AB. So the final result is F equal not C and AB. So, okay, I can see. There's another exercise. You have this table, this Carnot map. And when you see first, maybe you can draw this square, and this one. Right? You can draw 3 square and you can get 3 expression. But in here, maybe you can see only 3, only 2. And if we write the 2 of them, it is the consensus term. You can eliminate the yz in the consensus term. And the simplest one is in here, this one. Because in this one, there is only 2 square. You don't have to use this one because in that value is in that value is also used. You don't have to put them together. With this, you would use all of the one term. Okay. Sorry, I can. Okay, there is another exercise. There is a function m 0, 1, 2, 5, 6, 7. This is a mean term also. And you can draw the Carnot, draw this table, draw the squares, and write the variables. This one 0, this one 1, this one 2, this one 2, this one 5, this one 6, this one 7. So you can take the squares like both of them. But if you use this both, you can do like that or you can do like that. You get the same expression. This 2 expression is equal. Okay, it is not important you write this one or this one. The result is same. This is not changing. So don't think I am wrong, I to get this, or I am wrong, I to get this one. It is not important. If you make a circuit, maybe you will use the logisim and make a circuit about this expression and this expression. You know the how to doing is, and you can show the result. It will be same. Okay, there is a 4 variable Carnot map. There is a AB and there is a CD. This part is 3 inputs. This part also have 3 inputs. So this part has 4 variable. Also this part has 4 variable. Okay. And you know the number is not continue with 1 by 1 because of the gray coding. You have to know this number because they give you only min term and they give you numbers like that. You have to put the numbers just 1 and you get the map. Okay, so take a look at that plot of ACD or not B, not AB and not D. Okay, let's see that. You have this function, this one, and you need to square. You have this one with 4 variable square. It means not A, B, and also you have 8 variable square because 8 is power of 2. As I said, you can use 2, 4, and 8. You have to use power of 2. You cannot use, for example, 3, 5, 7. You have to use number of power of 2 for square, for cluster. It is kind of clusters. So that means you cannot take this. This is 3 variables. You have to take this one. Okay. So take a look at this. There is a 4 variable in here in corner. There is a 4 variable in here in corner too. And you can just look which one is not changing. A is changing because it got 0, 1. Also C is changing because it got 0 and it got 1. D is not changing, it is just 0. So D also changing, you can get D. And in here square you get this, and in here squared you get this expression, and you get final answer. Okay, just take a look another exercises. There is this function f1, they said 1, 3, 4, 5, 10, 11, 13, and they write the numbers. Okay, so and you can draw the square like that, Which one is not changing? A and B is not changing, and they got the 0. Not A, not B. In here D is not changing, it got 1 and D. It means not A, not B, and D. this one, and also you have this one, and also you have just one value in here. You cannot left any value, any one in the calculation. You have to take all of them. If there is a one, okay, it's not important. It means there is no simplification about that, and you have to take all of the gates. One means A, not B, C, not D, and this one. You don't get the square all time. Sometimes you get just one volume. Okay, so there's another exercises. You know that there is a this and this square. Also, you can get this and this square, maybe. It is not important. You can try. It will be always the same results. Okay. In the last lecture, I think we saw the not care variable. Okay. What does it mean? Don't care term. It means you can took 1 or you can took 0, whatever you want. Which one is easier, and choose this, that one, and for example, you have this square. It is constant, but if you take the x 0, there is a 1 in here, and it will be alone, and you can take this one. You should take this one. But if you consider x a 1, you can get a good square. No, you have to draw the circles. I only give you this expression, and you have to draw the Carnot map, and you have to take the squares, and it is your decision which squares you want to take. And if you get this x1, so you got good squares, and the simplest form is like that. Okay. First of f, we always use the mean term, right? We always take the 1. But there is a examples about take max term. It gave you same results. If you prefer, you can do the zeros for the same process. But in the ones, you use AND gates, the combine and OR gates for the components. But for the zeros, it must be product of sum. In the mean term, it is sum of the product, but in the max term, it is product of sum. First, you sum of the variables, then you product the components. In the mean terms, first you have to product the variables, then you sum the components. Okay? This is the same rules. Determination of minimum expression using essential prime implicants. So, what is the essential prime implicants? Because you can use this square or this square or this square. There's a 3 squares, right? Which one is the essential prime implicant. This is important. It is obviously this one, right? Because this is the simplest one. In here also there's an example. This one and this one. This is also prime implicant. This one we cannot use the square as a square, so it is not the prime implicant since it can be combined with other terms. It is not combined with other terms because we already has this square, and this square. If we use this square, this one and this one, two variable will be not prime implicants, and it will be a problem. It not be a simplest solution. Okay, there's another example. You have to do a lot of exercises about that also. There's a simplest one in here, because with this model you use this one and this one. With this model you get three expression, this result. But with this is kind of complex. You can get this one, also this one, 2 also this one, 3 also this one, 4. You have 4 expression. In here you have 3. Only 3. This is the simplest. Okay. Let's see determination of minimum expression using essential prime implication and continue with that. First, find essential prime implicants. Second, if min terms are not covered by the essential prime implicants, only more prime implicants must be added to form minimum expression. It is just and try. Try to find the simplest one. If you don't find the simplest, and try again. So in this example, they use this square. It means not easy. They use, I think, this square. It means not A, not B, not D, because D is not changing, A and B also not change. And use this one. A is not changing, C and D is not changing. So you have one left, right? This one. You use this square, and this square. You get one left. In here, you can use this one, this square. Also, you can use this square. It is not important. You can use this expression or this expression. Okay? Both of them is the simplest one. This is your choice. Okay. Why don't we take 7, 5, 11? We cannot take 3 variables. It have to be power of 2. It have to be 2 or 4. It cannot be 3 or 5 or 7. It has to be 2, 4, or 8. It has to be power of 2. Okay. There is a flow chart about that. If you be a software designer, you will use a lot of flow charts. You know flow charts, right? Do you know flow charts? Okay. There's a beginner, choose a one which has not covered and find the adjacent ones or not care. You can use not care, as you know. So are the chosen one and its adjust ones and not cares covered by a single term? If it's yes, then that term is an essential prime implicant, loop it. Okay, if it is not, just jump this process and go there. All uncovered ones checked. All of them is checked or not. If you not change all of the ones, then turn the beginning. If you cover all of the one, then continue. Find the minimum set of the prime implicants which covered by the remaining ones on the maps and stop. This is the flowchart of the Carnot map product. Okay. Not AB covers this one. Let's see 1, 6. Let's see the 6. And it's just essential prime implicants. It is the essential prime implicants. Okay, you can use that. Not A, not B, not D. This one. This. Also this. Okay, it is the essential prime implicants. You can use all of them. There is, because if you don't use this one, the 6 will be alone. If you don't use this neighbor, 10 will be alone, but it is just neighborhoods. This is just not essential, but it is prime implicant. You have to use that, because if you use this one, okay, sorry, if you use this one, there is a 13 and 10. It will be alone, and it is not wanted situation, because the alone one is the hardest one, because in the alone one you have to use all of gates, all of inputs. We don't want it. You try to take all of in a square, but you cannot. If there is a one alone, it is not important. Okay, let's see 5 variable map. We saw the 2 variable, 3 and 4. What about 5? We said that we create a kernel like that. There is a 2 parts, there is a 2 parts. Also, there is a 2 parts, there is a 2 parts. But in here, in the 5 variable map, you should use 2 tables. For A is 0, for A is 1. You have to do all of them. This is kind of complex. In the next week, maybe we will do some exercises about 5 variable maps. This is the same rules, but you have to think about 2 dimension, 2 tables together. You have to consider these tables with together, like that. For example, there is a one function, this one. You know the numbers of the squares. Because of the gray coding, you cannot count by one or by. So take a look at this. In here, you write the ones and you take this class, okay? And you get not B and also not E, also not A, this one. A is 0, it's not changing in here, right? B is not changing, B is also 0. D is not changing, D, sorry, E, pardon. E is not changing, E also 0. Not A, not B, not E. So, this one, in this one, E is not changing, is 1. Also C is not changing, is 1. A is not changing also, is 1. A, C, E. I said that you have to think two table like a just one table. You have just consider the combine the tables and just try to draw a circle like that. That one. There is a 1 in here. There is a 1 in here. They are symmetric, right? Symmetric. It is 0, 1. It is 0, 1. It is this. It is the same. Only changing is A. And you can think about that as a square. It is not important. Don't think about that square. You can write this expression and you can write this expression and you can see that there is a simplification. Like that. Let's write that. Just write this one. What would be? It would be not A. Also B is not changing. Also C is changing, C 1 and 0. D is not changing, but it is 0, not D. And E is not changing also, it is 1. In here, the same. A is not changing and it's 1. B is not changing. D is not changing, but it's 0. Also, you got E. You got this term, the same, parenthesis. B not DE, and you got not A plus A, it means 1, and you get this. Okay, it is not important seeing this square. You can take a separate. And the simplest one result is in here. Okay, I think you got information about the Carnot map. It is very enjoyable to try to study on the Carnot map. I recommend that you do a lot of exercises. Maybe in this week I will send you a homework or something. I don't know. I'm trying to fix about the email problem. I have an email problem about the university. If I fix it, I will email all of you a homework. Maybe not, I don't know. This lecture is finished. See you in the next week. If anything change, I will be announced. I will let you know about that. See you next week. Bye. Thank you very much. Thank you. Have a nice day, all of you. Bye, guys.